Our next speaker, Darren Gallipeau, is Program Director for Imagine Communications' Xenium platform, a microservices technology that underpins their virtualization products and services. Darren?
Thank you, Bill. Okay, hello, good morning, everybody. So what I'm going to be talking about today is microservices, which is somewhat of a buzzword topic of late. But where I'd like to start is with a little bit of context and how we've got to microservices as a topic of conversation. So what this really is an evolution from this transition away from what are traditionally big iron appliances to solve a solution. This has applicability in not just file-based workflows, but also applicability into live and linear distribution models. And what it really represents is the ultimate sort of evolution away from those big iron appliances. So what gradually ended up happening is we started having a broader adoption, broader acceptance of software-based processing. This processing would often be deployed on commercial off-the-shelf server appliances. So this is really where the industry started saying, okay, we accept the concept of running on software. And then we started looking at how do we expose that a little bit further. And they started to say, well, okay, we're going to look at virtualization schemes. And cloud became a big popular topic of conversation at that point in time. But what we were really talking about doing was really taking those same applications that are running on that COT server. So these big so-called monolithic applications that were running on those COT software, and then we would really just wrap them in an image and we would run them in that cloud. We started hearing about containers and containerization, and this is sort of also a high topic of conversation, but still what we're really doing with that is we're taking those big monolithic applications and we're creating containers out of them, and then we're deploying them. So we're not really achieving a lot of the great benefits that are possible with virtualization and with cloud, and that's really what microservices is striving to achieve, really trying to make a more dynamic deployment, a more dynamic architecture. So again, when we start talking about microservices, it's often in relation to a monolithic style architecture. In an easy way to describe it, what we're really talking about is that in a monolithic architecture or a monolithic application, what we have is a bundle of services or a bundle of functionality that are all built into a compiled piece of software. With microservices, instead, what we do is we isolate those various functionalities that might be included in a particular piece of software, and we make them accessible via a common UI or a common API or service bus. An example that we like to use of this is that of a text editor. So you might need just a spell checker functionality, but to achieve that or to obtain that functionality, you need to purchase and install, deploy a full text editor. With a microservices style approach, you would instead isolate that spell checker functionality, so that's all that you're looking to deploy, to purchase, to run, just to achieve that small functionality. And that's just one example of how microservices differ from that of a monolithic application style architecture. So how do we define a microservices architecture? Well, first off, microservices are both an approach to software development as well as an approach to system design or system architecture design. So this is one where it's not just the development vendors, the technology vendors that have to take this microservices style approach, but also those who are deploying that software, people who are creating the systems that are making up their broadcast environment or whatever their media processing chain may be. The concept is that each of these functionalities are represented in isolated modules. Each of these isolated modules have defined in and outs and a very defined and simple set of parameters associated with them. You would chain these individual modules together in various ways, various combinations to achieve that full end-to-end workflow that you would otherwise use a big monolithic or a subset of a big monolithic application to achieve. In addition, what we try to strive for with these monolithic applications are common or standards-based interfaces. The concept is that we aren't chaining them together using some proprietary communication structure, but instead, the interface is both a control plane for those microservices as well as for the data transfer between each of those microservices is a common one. The concept is that you can mix and match various microservices much more easily in that way. So this is actually very similar to a SOA-based architecture. And oftentimes when we start talking about a service-based architecture, people point to a SOA-based architecture. Now, the big distinction between those two is that whereas a SOA-based application is really looking to perform or provide a common interface for these big monolithic applications to communicate, instead what you do is you have a conscious decision towards the functional decomposition of those functionalities represented in that monolithic application. Each of those individual functionalities are represented as separate services. Each of those services are communicating via that common service bus like a standard SOA architecture, but they are isolated in their process and they're isolated in their versioning and control, as we'll see a little bit later. So this is a simple example of a SOA versus microservices solution where in a SOA-based architecture, we might just have 3 monolithic applications that are running together, communicating across a common service backplane. So you might have your user account application, a shopping cart, and a product catalog. Very basic. Well, what you would instead do in a microservices approach to solving this particular problem is to break each of those down into their smallest reasonable business value. So you would have one specific service that's responsible for sending an email that might have applicability into multiple different facets of what would otherwise be your monolithic application style approach, but it sits separately and is isolated. Likewise with the user interface, with the database backend, with updating the display. This would be an example of a microservices approach. So what are some of the characteristics that compare monolithic applications with that of a microservices approach? Well, first off, with a monolithic application, it's built in and it's very reliant on interdependencies between those various features. So if you consider the concept of modifying one particular facet of an application, a monolithic application, maybe to add a new functionality or to modify an existing functionality, it has a very real and tangible impact to other parts of that application. Oftentimes, this can introduce regressions and difficulties with that update. Whereas with microservices, because of the isolation of each of those individual microservices, that's much easier to do. You don't have to consider the impact of that update or modification to that specific microservice across the various other microservices that might be making up your end-to-end solution. This kind of extends to the concept of versioning. So with a monolithic application, if you think about adding a new feature, what you're often getting when you finally get access to that new feature is a number of other features that you may or may not want, and they're controlled by one big application version to get access to that one little feature. When you use a microservices style approach, you have this option or this consideration of a continuous innovation, because what you need to update is just that one microservice, and you can have it independently versioned from the other microservices. So rather than being tied into one big boat of that monolithic application, you can keep them isolated. Again, this kind of extends into the concept of complexity. So these monolithic applications entail a lot of functionality that are often very interdependent and entwined. And making those modifications can often be very complex, especially over time. As you have a more and more mature product, it in fact generally has less stability than at the initial implementation of that particular application. Because as you make more modifications to that code, it becomes more brittle, it becomes more prone to regressions and difficulties in adding new functionality. With microservices, you strive for a simple functionality and a simple interface. Because of the isolated and simple nature of those microservices, the modifications or changes are often much easier to make and much less risk-prone. So monolithic applications are often more closed. And what I mean by this is that, and this is often something that we try to overcome a little bit, but what I mean by this is that the application itself is much more difficult to add external vendor or third-party functionality. So kind of a halfway point to this would be plugin architectures, where you might have something like Adobe Premiere, or you might have other editing tools where they have separate plugins that you can add in. Well, that would be sort of the halfway point towards what microservices offer, because instead, with the microservices, because you have these defined and isolated microservices, it's a more open architecture. You can really see what's going on in that end-to-end workflow, and you can actually modify it and add new vendor technologies in place. Oftentimes with monolithic applications, they're cloud-enabled, and this is really what I meant by the concept of taking an image of a particular application and then just loading that into the cloud. It's not really leveraging the benefits of the cloud, the agile nature that the cloud offers us, and that's really what microservices, by virtue of being lightweight and more portable, are offering us. And then there's this concept of horizontal scaling versus vertical scaling. And I think it really depends on whether you're sitting or laying down as to how you're going to view this. But with horizontal scaling, if you want to add more channels, what you do is add more and more big applications. With vertical scaling, you add new functionality without necessarily representing that new or representing complete deployments of those individual monolithic applications. And we'll see some examples of what I mean by that. But vertical scaling really just gives you another way to scale your processes because you have that effect with microservices. We often like to use Lego as an example on the benefits of granularity or the benefits of microservices. So with a set of Lego pieces, what you have is a set of variously sized pieces of Lego. And you can connect these pieces of Lego in a common way. And so if you think about what a piece of Lego, it's got that little round little connector piece, and every piece of Lego that you have can connect to that. You can build up very complex solutions, sometimes by having little customized pieces, but you build these up by stitching these small little blocks together. By contrast, what you have is this thing on the left, these big building blocks that are typically approached, and they are really kind of the analogy to monolithic architecture. So we like the Lego analogy because not only can you create these new customized solutions, but you can actually mix and match them. You can reuse them in other solutions. And this is really kind of what microservices strive to offer as well. Okay, so some of the other risks with monolithic applications, and it really kind of revolves around the idea that what you have is a big black box of functionality. And that big black box of functionality really kind of relies on that particular technology vendor to affect any sort of change or update to it. So if we need some new feature or functionality, we are basically beholden to that particular vendor of that large monolithic application to make those changes. And when they make those changes, again, because of the brittleness of the application, it's much more risk prone. And that risk often means additional costs. And that cost is borne by the actual operator or customer. That risk grows, the complexity grows, but also time to fulfillment grows. So what it ends up basically amounting to is that the customer has less flexibility in actually achieving these new end-to-end workflows or adding new functionality, because it's all tied into the release cycle and development path of that larger monolithic application development partner. So by comparison, microservices have a number of benefits, the first of which is that of efficiency. So considering the idea that when I want to achieve one particular functionality within a particular monolithic application, I don't get to pay for that one subset of functionality. Going back to that text editor example, if I just want that spell checker functionality, I have to purchase and install and deploy that large text editor. With a microservices approach, what you just pay for is just the spell checker functionality, and that's all that you have to consider, both with the purchase and operational, but also the resource footprint that's associated with that particular spell checker functionality. That overall results in a more efficient, economically, model. Because we're ideally working with a common set of APIs, when we introduce new functionality or new vendor technologies, those common APIs mean that the integration is easier. So instead of working with a customized API or custom SDK, it really should work on those common set of APIs, thereby reducing the cost further. The isolated nature of these microservices also possibly mean that it's going to be less expensive to add new functionality or to address new functionality to your end-to-end workflow. The concept is that you're going to aim small, and so you're going to miss small. So if you're trying to make big sweeping changes, you're much more prone to error than the small little changes that you can achieve by using a microservices architecture. And then finally, there's this concept of maximum utilization. So the example that I often like to use here is one of a jar. And so if the jar represents your total operational capacity, and this could be computational capacity or network capacity, and you try and fill that with a set of bowling balls, you're going to have a lot of wasted space inside of that jar. If instead you fill that jar with a set of pebbles, you're going to have much less wasted space, resulting in a much more efficient workflow. And so you could, in fact, by that token, reduce the overall size of your jar and thereby improve the efficiency and reduce the costs of your overall system workflow. But probably the most compelling of microservices is that of innovation and flexibility. And so this is the idea that we can mix and match technologies much more easily than you can inside of a monolithic application. So because each of those microservices have a clearly defined functionality, you could swap new functionality very easily. And so a standard example might be that of a file-based transcoding solution. So you're going to have your media source, some form of disk access and decoding. You might have some inline video processing. And then you're going to have your encoding and then your disk write on access. So if you wanted to swap between something like an H.264 encode with that of an HEVC, with microservices, you don't deploy a whole new solution that encompasses all of this functionality. Instead, you swap out the one microservice that's pertaining to that compression technology. Now, sometimes that's not going to work. This is an example that might be better served with microservices that offer in-memory or RDMA style interfacing, but it does conceptually work both with IP as well if you're using some form of uncompressed transfer between those various microservices over IP. So this extends to the benefits with respect to collaboration. And again, this ties into the idea of not being as tied to a singular vendor for your full end-to-end workflow or for your full monolithic application. And so this is about the idea that these interfaces are clearly defined and they're exchangeable. So if I want to introduce a new technology from a different vendor, I don't have to worry about integrating that new technology into a big monolithic application. Instead, I swap out the new microservice, and I can achieve that new functionality as simply as that. So one of the topics that often come up is that of VMs and containers. And we've seen this a lot with microservices, where what many people do is they say, OK, I've got my application, and I'm integrating it inside of a container, and therefore it's a microservice. We would contend that this is not actually accurate. Virtual machines and containers are really computational surfaces. What they are they environments to actually perform the operation. It's important to distinguish between the actual compute environment and the actual operations that are being taken in that environment. So what this means is that you can actually deploy a microservice on a VM. You could do that, and it would still be a very valid microservice architecture. You could deploy it as a container, and that might actually be a more efficient way of using your system. But neither one needs to be used. In fact, you could deploy a microservice on a bare metal server and still have it as a valid microservice. The concept here is that simply saying that it's a container or saying that it's cloud does not make a microservice. What makes a microservice is all of those characteristics I've described before: isolation, granularity, extensibility, and standards-based interfaces. VMs and containers are really just the operational environment. So we really shouldn't conflate the two, although they are complementary in maximizing the efficiency and operational capacity of our systems. Okay, so what are some of the challenges with microservices and broadcast? Probably the first of which that most of us would encounter is that of existing infrastructure. As much as there's been an active transition to COTS-based servers, we still have heavy investments into those big iron appliances and SDI-based coax cables running through our facilities. And that's really just something that's going to be an ongoing issue. And so what we generally recommend at this point in time is to consider a more hybrid approach to your deployment. So one of the things that's nice about microservices style architectures is that because of their isolated nature, you can often bring them in without interrupting or damaging your other operations. So that's generally the approach that we're seeing with existing infrastructure. But a probably more notable difficulty is that of existing personnel. Because what we typically operate with is a broadcast engineering perspective. And that's a little bit different from the typical approach for microservices, which is really more of an IT-centric approach. So in a broadcast engineering approach, what you have is you have engineering and then you have operations. Engineering goes and they designs their particular solution, they implement it, they kick it off to operations, and operations runs with it. In more IT-centric type deployments, those are really one and the same people, and the term we often use for that is DevOps. That's really where you're going to see a lot of the benefits of a microservices architecture, because you can respond to changes much more quickly without having that separation of engineering and operations. And it's with that approach that we're probably going to see the best adoption and best use of microservices. The other difficulty is one of just complexity. So we say that each of these are simple, and each of the microservices are inherently more simple. But together, we're talking about a large number of separate services that need to be coordinated and they need to be managed. And this is not a simple problem to solve. Now, it's simple if we have just one microservice or a couple microservices that are doing one subset of our operations. But if we're having a wider scale and sweeping change, we're going to have some pretty complex or intelligent orchestration services. And this includes not just managing the individual microservices themselves, but the actual network architecture or infrastructure as well. This is where we start talking about SD&O and the like. And so there needs to be this orchestration considered when moving to a microservices style architecture. We like to bring this up because what we're talking about is trying to strive towards common interfaces. So we can have microservices that aren't necessarily using standards-based interfaces, but we should strive for that, where really what we try to do is separate the actual communication plane from the actual operation itself. The quote is that we're looking to have smart endpoints but dumb pipes. So we're really trying to have the most simple communication possible so that we have that portability and extensibility across microservices. So microservices are not actually new. They are new to our industry, but they've been used heavily across multiple other industries: telecom, web hosting, financial, security, as well as these ones on the right. And I kind of want to call these out because what they represent are some of the biggest disruptors in our industry today. And all of these companies heavily leverage microservices and have done so very successfully. And because of that, use of microservices, and also because of really big bank accounts, they've been able to introduce new competitive services that have been heavily disruptive to our industry, and we can't respond as quickly because of our traditional approaches to things. And that's really what microservices should mean to us. It's this idea of adapting to changing market conditions, being able to respond quicker to changes in consumer consumption habits without having to go through the standard engineering and then operations with big monolithic applications, deployment with regression testing, et cetera, that's associated with a monolithic application. And it's with microservices that we really should strive to have an answer to those competitive influences of those various other industries and companies entering our space. Okay, so how does this actually work in the broadcast and media industry? Well, what it really means is it's about the convergence of various things. So the reason that microservices are actually more of a potential reality in our industry is the convergence of things like the speed of processors. So no longer do we need high-powered dedicated ASICs to do our processing. We can achieve it with not very expensive off-the-shelf processors. It's the standardization of communication protocols. So things like 2110, SMPTE 2110, because of this agreement in the industry of how we're going to handle uncompressed over IP, it really means that it allows us to have new microservices introduced and exchange across multiple vendors that this is going to be possible. The other thing is you might say, well, okay, if I separate all of these various processes as separate services, I'm going to have to communicate with them over IP, and isn't that going to overload my network? Well, possibly, if you're doing a whole bunch, but honestly, with network capacity today, we've just seen huge advancements. I mean, even just this year, AT&T successfully tested a 400 gig network. And in fact, it's more common today to be provisioning 40 gig and 100 gig network switches than it is 10 or 1 gig. Network capacity is becoming so fast that that's why these microservices style approaches are much more viable. Okay, so I don't have much time, but this is an example of a microservice in action. So what this is a broadcast playout channel. And so the example that we're showing here is that instead of having 5 different separate broadcast playout channels for 5 different branded instances, instead what we can have is 1 broadcast playout channel, but 5 separate branding microservices across that. And in that way, you can actually achieve efficiency. This is just one real-world example of how microservices have provided a more optimized approach. Okay, so in conclusion, our contention is that microservices offer us a way of being more flexible to responding to market conditions, to produce more efficient and cost-effective solutions to the problems that our organization is facing. But it also that microservices offers a better collaboration and better flexibility for our customers. And really what this is all about is responding to changing market conditions and disruptions in our industry, because really that slow speed to response is really a big concern for most of us in the industry. We really need to be able to adapt to these changing market conditions, and we think that microservices are a potential way of doing that. Thank you.